Guys, welcome back to our channel. Today we will see NXCAM tutorial, face milling, cavity milling, rest milling, all about 3 operations in one workpiece, explaining each and every step as per industry standard.
Have a good day. In this exercise, we are going to explain face milling, cavity milling and rest milling operations. We already created many models so that directly I can go for import the model. Now this model has been created already. In this model or in this workpiece, first I will do face milling, then I will do cavity milling, then rest milling. We can go for geometrical view, go to machine mill, MCS mill means machine coordinate systems. We go to edit it and we go to specify where is your MCS. You can put any place as you like it. Normally we will go for UCS and MCS should be in same so that it will not create any problem in future. Both should be in one condition means you are having some advantages. Clearance option, save clearance 10 mm means the cutter should come from spindle and it should stand 10 mm above from the workpiece. Next one, we go to go for workpiece, edit, we go to specify part, which is your part, this is my part, and you go to specify blank. In this blank, go to bounding block, I make it 2 mm blank thickness higher. By this face milling, I will remove 2 mm from top surface. So far we have completed machine coordinate system mill and we have completed workpiece. Now we will go for create operations. Go to face milling with boundaries. In C program, we can go for program tool. Here we have to select the tool. MCS mill, we have to go for workpiece and method. Directly we can go for finishing. Here specify face boundaries. Which material, which area you are going to machine it. Go to specify face boundaries. Click this surface. This area I will remove the material of 2 mm. Means by using face milling operations, I remove the stock of 2 mm. Then go to tool. We go to create new tool. Here retrieve tool from library. In this milling options, there are n number of cutters available. We can go for face mill with indexable. Matlab carbide inserts you can take it. So in face mill, ready-made 100 mm available, 43, 60 mm, 64 mm available. So for machining purpose, I am taking face mill 43 mm. Take it preview. Then method is mill finish method, and I am not going to give any allowances for future machining. Part stock is 0. Pattern, there are number of patterns available. How do you cut the workpiece? By using follow part or follow periphery or mix or profile method, zigzag. I am taking it first follow part method. Step over of percentage of tool. After completion of one cut, how much distance move for crosswise? Normally I can put it 40 to 50, make it 50. That blank distance I already given in specific blank 2 mm. So we have to indicate this 2 mm. If we will give 5 means you have to write 5 mm. So we have given and we have defined already 2 mm, so that we have to put 2 mm. Then depth of cut. For showing purpose only, I am putting 0.5 material. Each and every time it will take 0.5 mm material. Means 4 times it will cut. final floor stock. In this floor I have not given any stock material, means I have to finish 2 mm material, so I have to put 0. Then cutting parameters, go to stock. In this part stock already defined 00, I am not giving any raw material. Then go to non-cutting moves, how to engage your tool. You can go for ramp on shape, or you can go for helical, or you can go for flange. Normally the industry we are using helical or ramp on shape. How we are going to retract the tool after completion of the workpiece, how the tool will come back. The same way engage after completion of workpiece, the tool will go 10 mm above. Is more important, feeds and feeds. We have taken material carbon steel, means mild steel, and my workpiece material is carbide cutter. So in this case we can go for 100 to 125 meter per minute. Now I am putting 100. You are putting, then calculate feeds and feeds. Automatically the spindle should run 505 and the feed 255. Sorry, 250. We have to go for optimize. So each and every times traverse, rapid, engaging, return back, all feeds are automatically calculated. Now we have completed each and every steps. Part we have completed, face boundary is completed, tool completed, and output we can go for put it 1, tool number 1, and cut pattern is follow part, step over is tool flat, and blank distance is 2 mm, depth of cut is 0.5. Then now we will go for generate the tool path. Go to toolbar, verify, take it 3D dynamic. For showing purpose I am is taking outside. Then it will complete all surfaces. Then it will go back and it will take depth. This is one method. Then another method, go to follow periphery. You can check it. Then go to another method, make it zigzag method. In this zigzag methods, the tool start from crosswise. Now you want to change it, instead of crosswise you want to change it in longitudinal directions. You can go for cutting parameters and go to strategy. Here you have to put 90 degree. Now it will automatically change in longitudinal directions. Now we will save it. Now we can go for verify. Slowly I have to show you that. This is zigzag methods. each and every time it removes 0.5 mm material from top surface. We get given blank is 2 mm, 4 times it will take that material. Then it will go back and it will go to start position. It will take depth, then it will move it. Now we can go for faster. Now first machining face milling has been completed. Now we will go for second machining. Now I am going to explain the second operation of cavity milling. We have to go for create operations. Cavity mill program is same. Tool, we have to select tool, workpiece and mill finish. We have selected our specific part already. We have specific blank already. We have to go for specific cut area. This area I have to cut it. So I can go and select like this. The top surface there is no need. So I have to put shift command and make it click. So there is no need to select this surface. Go to tool commands, create new tool, go to end mill options. Now I am selecting end mill 10 mm and description you can put end mill 10 mm, you can write down for your reference, and tool number is 2. Then go to OK. Then go to finishing method, and I will not give any material for future machining. 0, already 0. Then cut pattern method, go to follow part or follow periphery. In this case I am taking follow part. Tool flat 50, I already explained that. The depth of cut is 1 mm. Cutting parameters same, non-cutting moves are same, and feeds we have to calculate it. Since I am taking n mill of HSS, the cutting speed is 30. Go for automatic calculations. Feed per tooth is 0.13. This RPM 955. You can make it 955 or you can make it 1000. Then optimize feed rate. Okay. Now we have completed all those things: part, blank, cut area, tool selection, method, cut pattern, constant depth of cut. Maximum is I will go for 0.5 mm and go to generate. I will select it. Then I will go to verify. Please carefully watch that what happened in this machining. In that machining, you please carefully watch that. It is not taking material directly. It is running above 2 mm. Have you seen? It is not taking material. Why? I will close it. Then I will show that one. Now you see. It is running ideally. It is not taking any material. Because the blank surface is there 2 mm. In this we have to edit and we have to put the tool should start from 0. You please see what happened. Up to 2 mm the cutter is idle. 4 times 0.5, 0.5, 0.5, 0.5 material. It was in idle. Now it is taking material from here. Now how to edit this program? Okay, go to edit. See here, cut levels. Here Z is already defined 2 mm. Now we go to put 0, means I go to start from 0, then it will automatically change the 5 mm. Now the tool surface second tool will come from 0 level to 5 mm. In this time there will be no idle cut, directly it will take materials. We will go and see. Now it is directly taking material from top surface. Previous time 4 times it was running ideally, then after for 2 mm it took material cut. Due to these changes, it start from 0 surface. Okay. Now you please see this material is not been removed because the cutter 10 mm cannot enter these small areas. So in this material we have to remove by using rest mill. What is meant by rest mill? Rest milling is one type of operations which the previous cutter or previous operations left the material. That material will be removed in rest milling. Now this material will be removed by using rest milling options. Now we will go for rest milling, create operations, go for rest milling options. Here everything is same. I have not changed anything. The tool, I have to select the tool. Here I will go and select the tool, means lesser dia, because previously 10 mm is not entered. So in this case I am going to put 6 mm cutters. The tool number is 3. My tool material 10 mm cutter is HSS. Percentage of tool meter 20. The maximum distance 0.5 material, and again you go to cut levels, you go to check it 0 surface, and it will go for up to 5 mm. Cutting parameter same, non-cutting move same, feed and feed we have to change it. This we have to go for 30 meter per minute. Now it is 0.0785 feet per tooth. Now the cutter 6 mm end mill should rotate 1592. You can see 1600. We go to optimize speed. Okay. Now we will generate. We go to check it. You see, intentionally I am doing some mistakes. We will see which mistakes normally people will do. See why it is selected, why it is going for outside material. I have not given anything, even though it is taking outside materials. Means this type of mistakes normally the CNC programmer or operator is doing. We go to go for OK and go to rest milling, go to edit. Here you have not indicated any specific cut area. You have to indicate, you have to tell surface. This is my surface and this surface. Okay. Now we can see. Now it is removing the material of 6 mm. Again you have to see. We have taken 6 mm end mill. Again still the material is there. It is not entered in this corner. Means we have to change the cutter size. How to change the cutter size? Go to rest milling, edit the cutters of 4 mm end mill. I have to take it and we can check it whether 4 mm is entered or not. Yes, now it is entered. Each and every time we have to see, we have to reduce the cutter size. Now it is removed. The important method is trial and error method. First, for roughing purpose, we have taken 10 mm end mill. It is not entered that corner area. Then second time you are putting 6 mm end mill. Again some of the materials left. Now we are taking 4 mm material, 4 mm end mill. Now it is removed everything. Means that 4 mm cutter is the final size of the cutter. Now we will select 3 operations and we will generate it and we will check whether all material has been removed or not. First it is removing face milling. Each and every time it is taking 0.5 material by using indexable carbide cutters. I made it a little bit fast. Now face milling has been completed. Now it will take end mill dia 10 of cavity milling. It is removing by 0.5 mm depth each and every time. Up to it will go for 5 mm depth. It is not entering because the diameter 10 mm cannot enter these small areas. This material will be removed by using rest milling. This is rest milling operations. The smaller tool, diameter 4 mm end mill, has come and take the remaining material which left the material of previous operations. Rest milling means in previous operations which material is left, that material will be removed by current operations. Now we will go and check it by analyzing whether all material has been removed or some material may be left. So, green color means 0.00 surface, so there is no material available. All material has been removed. Facing, cavity milling and rest milling, all material has been removed. Means our operation is okay as per industry. We will save it. The next step is going to post processor, means convert this program into CNC milling and convert the program into G codes, M codes. Then only you will transfer this codes to CNC milling. As per your this program, the cutter will go and cut the material in the workpiece. Post processor. Go to, there are number of post processor available. We can go for mill 3 axis or you can select it any one post processor. Here decal mago post processor there. Cinematic is there. Cinematic two types of there. 840D IN. IN means inch. 840D mm means metric. If you are selecting IN means it will give the reading of inch. If you are selecting 840D mm means it will give metric. By default I am taking mill 3 axis. Okay. Output file, where you want to put this output file. This is important point. Post processor you want inch or metric. In industry we are using metric. We can go for metric. Then go to OK. Now post process has been completed and it is converted the program into G codes, A codes, and you are knowing that G40 cutter radius compensation 0 or cancel, G17 XY plane and tool plane is in Z axis, G90 absolute coordinate system, G71 metric system means the reading will be in metric, G91 incremental coordinate system, G28 reference point, T01 tool number 1, M06 M06 spindle automatic tool change holder. All process has been completed. Tool number 1, 2, 3. Finally, you can also edit it. N 8 9 2 0 M30 program end, and you can save it. Now another important operation is go to simulate machines. In this machines we can go for machine tool view, generic machine, go to edit options, retrieve machine from tool library, and go to milling options. Shop floor you may have FUNUC or hidden end or cinematic processes. You can go for FUNUC by default, or hidden end or cinematic. In this case I am going to take FUNUC. Then where you want to put the workpiece, I am putting here this center or corner or any one place you can make it. The machine has come. Okay, then you go to simulate machine, go to material removal, make it a little bit zoom. First tracing operation is coming. I made it a little bit faster. Each and every time it is taking 5 mm material. Four times it will take 0.5 material, 2 mm material has been done. Now first facing machine is completed, then it is taking cavity mill. Some materials left behind because the 10 mm cutter cannot enter the inside. Now it will take 5 mm material. It has to take. Then third operation will be coming, means rest milling. Diameter 4 mm I have taken it. Now all three operations has been completed: face milling, cavity milling, and rest milling. Now final step is documentation. We go to documentation for your future reference. Here it shows that unit is in MO, three operations: face milling, this cutter, it took 16.48 minutes. Then second time is cavity milling, it took 16.84 minutes. Then rest milling, it took 12.18. You can keep this documentation for your shop floor purpose. You make it documentation. In future reference, you can verify, you can check it, how much time it was taken. In this exercise, we have explained face milling, cavity milling, and rest milling. We will close, save all, and exit.
Thank you for watching. Please like, share and subscribe. And if you have any doubt, kindly let me know in comment section. Thank you for watching. Please like, share and subscribe. And if you have any doubt, kindly let me know in comment section.